As you mentioned, my name is Wang from Samsung UK. I'm also the ENI secretary and the rapporteur of the use case work item. I hope by now with this presentation you have got a pretty good idea of what we do in ENI and what we are aiming for. So here I'm going to go into a little bit more detail of the use cases as some of the examples to show you how the use of ENI system can really benefit the network and to enhance the operator's experience. Just to give you a very brief overview of the use case work item, well, it's about identifying and describing the appropriate use cases and scenarios through the use of network intelligence and to enhance the network experience. As Ray mentioned, we have output as a group report, which you will see very soon. It detailed where the intelligence can be applied in the fixed and the mobile networks. And it also gives a baseline on how the studies of ENI will substantially benefit the operators, which we will see from the later examples. Now, this use case work item started in April when in the ENI kickoff meeting. We had the first draft in May, and by December we had a stable version, and now the final draft is for approval. You've seen these slides. So we have identified 14 use cases, and they are categorized into 4 categories on the network operation, the service administration and management, and the network assurance and the infrastructure management. So in the following, I'm going to give you some examples of the use cases to see, hopefully, to see the benefit of the ENI use cases. The first one is policy-driven IDC traffic steering. IDC is the Internet Data Center. And we know that currently there are multiple, basically a number of problems when allocating the multiple links between the IDCs. So, for example, the network operator will always select the path following, for example, a shortest path strategy. But this obviously is not always optimal, especially when you consider, for example, one of the link is already heavily loaded. And so link load here is not sufficiently considered. And on the other hand, when you allocate too much bandwidth to one of the talent, it's not always fully used all the time. So it's a waste of the network resource. What AI and the ENI system can help you here is really to autonomously monitor the services and allocate and optimize the network resource through historic data or the prediction in real time. So according to the dynamic change of the service traffic, it can really do a load balancing in real time. And in such a condition, the network resources, for example, the bandwidth, can be used more efficiently. And now the second one, this is my personal favorite use case, is energy optimization using AI. We know that the energy consumption in a network costs up to, I think, 40% of the network OPEX. And according to our China Telecom colleagues, the servers in a DC actually takes 70% of the total power consumption. So it's a huge amount of actually power consumption. And it's a big waste because the servers are actually deployed and running to meet the requirement of the peak hour service, like 100% powered up full time. But it's not necessary because we know the service traffic can be very dynamic. So, for example, at 7 o'clock in the afternoon, you probably want to turn power up more servers than 12 o'clock in the evening at night. So what AI and ENI can really do here is to learn and update the usage pattern of the services. You see, for example, this curve shows how the traffic goes through time for different hours of the day. So you can really adjust your servers to power them up according to this traffic, and to autonomously turn the spare servers up or turn them to the idle state according to the different traffic. And in order to guarantee the service, on the other hand, you need to predict the peak hours and to wake up the necessary number of servers when you predict, there is going to be a high high requirement for the servers. The next one is the policy-based network slicing for IoT security. Security, again, a big topic and a very challenging one, especially when it comes to the IoT context, because there is a massive deployment of the devices and adding on the dimension of complexity. There are also slices, and they can be dynamically, adapted and expanded, and the methods and technologies of attacks can be widely changing. So that makes the attack very easily to be spreaded. And so what we are saying here is AI and ENI is not about to really detect the attack, but rather to detect the abnormal behavior of the device by monitoring its behavior. So for example, it suddenly have a large output of data, or it suddenly reduces the traffic. So those abnormal behavior of the devices will be detected and then automatically isolated. I was trying to, so automatically get isolated, so it stops it from the attack from spreading. And the next use case I want to show you is the intelligent front hall management and orchestration. And so we've talked about, the intelligent at the run, at the core. In the 5G and its evolved version, there's also front hall, right? We have the RAU on the one side, we have the RCC on the other side. So there are actually multiple factors, and the changing context in front hall is very complicated, and adding to it is a flexible functional split. So you might want to assign some of the functional blocks to the RAU and some of them to RCC. So this is very different from the conventional problem where you can't really model an optimization problem and solve it. This is where machine learning and AI can really do its best, because it doesn't need a model to optimize the network resources according to the changing traffic and the context. This one, I don't think I need to say much about the slice management. So basically what we are saying here is you see you have this slice management and orchestration, and you can have a ENI system that will really assist you to intelligently manage your slices that also include, the analysis of the data associated to your traffic load, your service characterization, your VLF types, and it can produce a proper context-aware policy to really tell the network slice management and orchestrator, to when, where, and how to place and adjust the slice instance to, in terms of reconfiguration, the scale in, scale out, up and down, and change of the template, etc. And dynamically change the resource reservation, of course. The next one is the assurance of the service requirement. We are talking about SLA today at the debating table. And so here the angle is from, sometimes the telecommunication service need to provide a dedicated slice to some of the, for example, the banking, the energy provider companies. And those are the vital applications of the network. But it's actually out of the core business of, for example, a banking company or energy provider company, and they have very strict requirements. Sometimes it's a personalized or customized SLA. And on the other hand, you don't want to just allocate a slice that is very expensive, to meet the maximum requirement. What you want to do is to optimize your resources and to predict the situation where multiple slices may be competing for the same physical resources, and you employ some preventive measures, and you can, using AI and ENI, to predict or detect a requirement change and to make decisions. For example, if you detect that there is competing resources in the different slices, you may want to increase the priority of a given slice, in order to meet the service requirement. So I think that's all the use cases, represented use cases I selected wanted to show you some examples, how those use cases or the ENI system can really benefit the network. So I think the concepts are actually similar, in terms of what AI and ENI can do. They can adapt to the changing context. They can enable the autonomous and policy-driven operation. They adjust their resource according to the dynamic context, and they usually do it real time or nearly real time. So in the end, we have optimized energy and network resource usage. We have enhanced the security, simplified operation, and guaranteed services. So that's the work we have done in ENI phase 1. We will have a phase 2 that hopefully will begin very soon after the phase 1 document is published. And now in phase 2, there is a new aspect in the ENI use case work item. It is where to, in addition to show you, the baseline of how the use cases can benefit the network, etc. We'll also show how the studies in ENI can be applied as a solution of the identified use case in accordance with the ENI architecture. So we'll take the input of the ENI reference architecture, we'll apply it to the solution of the use cases, and we give feedback to the network architecture work item. And I think that's all about the use case work item. Obviously, here is a contact if you are interested in any of the use cases or have any questions. I'll say a few words about the requirements and terminology on behalf of the rapporteurs who are both from China Telecom. So this is an overview of the requirement work item. Again, it started in April, and now the final draft is sent for approval. Now, this is a group specification, and it specifies the requirement of how intelligence is applied to the network to improve the operator's experience, and the main purpose of this requirement document is really to provide the result of the study on requirement for the architecture design. And so there are two levels of the requirements, and on the higher level you have service and network requirements, so functional and non-functional requirements. And when it goes to level 2 requirement, it becomes a lot more detailed. And if you are interested in any of the requirements here, you're welcome to have a look at our group specification. The next one is terminology. Well, it started a bit later, in August. It really is to achieve a common language across all the ISG and I documentation, because in the discussion we had, people have different understanding of intelligence, AI, machine learning, the scope of the work, etc., etc. So there are lots of debates, but the purpose of this work item is really to provide a common understanding. So if you have any questions, obviously here is the contact of the rapporteurs, which you can contact them to, or contact Ray, the chairman, to if you have any questions. And so from here, I'll hand it back to Ray on the intelligence policy management.